Hi, my name is Kaylee Carruthers, and for my final presentation, I will be discussing how my group used the process of radio astronomy to identify an unknown radio source. To begin, there are a few important terms to define to adequately understand the experiment that we conducted. The first and most overarching one is radio astronomy, or a subfield of astronomy that studies celestial bodies at radio frequencies. Astronomers use this to identify radio sources, or objects in outer space that emit strong radio waves. In this experiment, we were informed of an unknown radio source at approximately 25 right ascension and 63 declination, and set goals to meet throughout the process. The first was to calculate the flux density, or strength of the object, then the spectral index, a more precise location, and finally finding a possible name of the object. To conduct this experiment, we used an online program called Skynet. With an account, this site allows you to utilize a radio observatory. The program conducts the observations through a 20-meter telescope in Green Bank, West Virginia. We inserted special data requests to receive the best observation possible of the source given our goals. We selected a daisy map with 8 petals at 45 seconds per petal and an angular size of 180 arc minutes per petal. A beam width of 0.75 degrees and a sun separation of 15 degrees were also requested to ensure that we had clear exposure of the object with as little interference from the sun and atmosphere as possible. After a few days, the observation from Skynet had been completed. Moving forward, we began collecting the data provided to complete our calculations. The first step was to find the flux density of our object using the equation displayed on the screen. We found the area of the dish to be 314.16 meters squared using the area of a circle formula and the known diameter of 20 meters. The temperature was found by looking at the slack unknown calibrated amplitude graph on the right and taking the peak height and the baseline temperatures of 42 and 40 and subtracted them to get 2. Multiplying all this data together, we got a number that then needed to be divided by 1 times 10 to the negative 26 to convert the unit. In the end, we got our flux density to be 17.57 Janskis. The next step in the experiment was to calculate the spectral index using the equation seen on the screen. We were given data from 2 additional observations of the unknown source to properly complete this step. The telescope that we used had a frequency of 1,395 MHz, and the log of this value is 3.14. And then we had to use the S value from our flux density calculations, and the log of that value is 1.24. The new S values that we got were 180 and 85, and the log of these numbers is 2.255 and 1.929. The new F values were 100 MHz and 500 MHz, and the logs of these values are 2 and 2.69897. We graphed the logs of these numbers as a scatter plot shown on the left. The slope of its trend line was found to be negative 0.85, which makes our negative alpha value 0.85. A graph provided by Skynet, shown on the right, was then analyzed to determine a more precise location of our object. The coordinates 7 degrees right ascension and 64.25 degrees declination were found by looking at the highest point of the graph. We then plugged these coordinates into Simbad, another online resource, to determine the possible name of our object. 2 results appeared: BWE 00256342 and TYC 40239491. TYC is a star, while BWE is a radio source. So in conclusion, it was determined that BWE was the most likely identity of our source, as a star would not emit the radio waves compatible with our object. Many other questions could be investigated following our experiment. Some of them that could be answered with further research include how far away is this object from Earth and how much mass does it contain. This experiment is an incredibly valuable process that radio astronomers use to identify unknown radio sources, and as they continue trying to comprehend the vastness of our universe, the possibilities for radio astronomy grow with it.